Hi, today we'll try to solve a problem from homework 2. This is the figure given. We are asked to find the value of force F1 and this angle theta. The given is this system is in equilibrium. Let's review some of our previous knowledge. We know that adjacent component is equal to force into cos theta. So for example, for this angle of 5 kilonewton and 30-degree angle, this side is the adjacent side because this is the closest one, and this side in the positive y direction will be the opposite side, and the opposite side component is sine multiplied by sine theta. And for equilibrium, summation of all the forces in x direction is equal to 0, and summation of all the forces in y direction is also equal to 0. We also know that moment at any specific point in equilibrium, summation of the moments are also equal to 0, but in this problem we don't need this one. Now let's take summation of all the forces in x direction. At first, this F2, which is 6 kilonewton, and this angle is 70 degree, which is first side from x direction, so it will be sine 70 degree. Now for F1, the angle is in the adjacent side, so it will be plus F1 cos theta. Now let's consider this 5 kilonewton. The component in x direction is in the negative side, so this will be negative 5, and the angle is in the adjacent side, so it is cos 30. For this 7 kilonewton, it's also in negative direction, 7, and if we consider this angle as a alpha, we can, as it is in the adjacent side, we can write it's cos alpha. Now we know that cos alpha is equal to adjacent side divided by hypotenuse. From this triangle, if this is alpha, this is also alpha. So we can write adjacent side 4 divided by 5. Now this whole thing is equal to 0. If we solve this, we can find that F1 cos theta is equal to 4.29. Now let's take all the force, summation of all the force in y direction. We can write 6 cos 60 because this is the adjacent side for y direction, and minus F1, this is in the opposite side from this theta, so sine theta, and it's negative side, that's why it is negative. Now 5 kilonewton, this component in y direction is positive, so 5, and it is in the opposite side, so sine 30. And for this 7 kilonewton, it is in the component of y is in the negative direction, so it's negative 7, and from the angle alpha, it is the opposite side, so it's sine alpha. And for similarly, sine alpha is equal to opposite side divided by hypotenuse, that is 3 by 5, and whole thing is equal to 0. And we solve this one and we find F1 sine theta would be equal to 0.352 kilonewton. So now if we divide the equation 2 by equation 1, what we can find is tan theta is equal to 0.352 divided by 4.29, and solving this we can find theta is equal to 4.7 degree, and this is clockwise because as figure we can see this is this angle. Now for finding F1 we can use this equation 1. From the equation 1, F1 cos theta is equal to 4.29, or F1 is equal to 4.29 divided by cos 4.7. Using the calculator we can find this is equal to 4.3 kilonewton. So this and this are the answers for our problem.